Welcome to the amazing world of quantum computing. Today we'll talk about a technology that can completely change our understanding of computational capabilities and open doors to a new era of information technology. What is a quantum computer? How is it different from a regular one? And why are leading technology companies investing billions of dollars in their development? Let's find out. Let's start with how our familiar computers work. They are based on bits, units of information that can only take two values, 0 or 1. It's like a switch. It's either on or off. All data in a classical computer, text, images, video, is encoded by sequences of these zeros and ones. Now imagine that instead of a simple switch, you have something completely different, a quantum bit or qubit. Unlike a classical bit, a qubit can be not only in state 0 or 1, but also in their superposition. This means it can simultaneously be both 0 and 1 with a certain probability of each state. To better understand this, imagine a coin. A classical bit is like a coin lying either heads or tails up. A qubit is like a spinning coin, simultaneously being in both heads and tails states until it falls. Superposition is the first fundamental principle of quantum computers. Thanks to it, n qubits can simultaneously represent 2 to the power of n different states. This means that 300 qubits can theoretically store more numbers than there are atoms in the universe. The second key principle is quantum entanglement. This is a phenomenon where the states of 2 or more qubits become interdependent, even if they are physically separated. Einstein called this spooky action at a distance. Thanks to entanglement, changing the state of one qubit instantly affects the state of another. Just like classical computers use logic gates, quantum computers use quantum gates. They allow manipulating qubit states, creating complex quantum circuits to solve problems. There are several ways to create qubits. These can be superconducting circuits, ions in magnetic traps, photons, atomic spins, or quantum dots. Each approach has its advantages and disadvantages. For example, superconducting qubits are easier to scale, but they require extremely low temperatures, about -273 degrees Celsius. One of the main problems in creating quantum computers is decoherence. This is a process where qubits lose their quantum properties due to interaction with the environment. To combat this, ultra-low temperatures, magnetic shielding, quantum error correction, and topological protection are used. Where can quantum computers be applied? First of all, in cryptography. They can break many modern encryption systems based on factoring large numbers, but they also offer a solution, quantum cryptography, which is theoretically absolutely secure. One of the most promising applications is modeling complex molecular systems. This can revolutionize the development of new drugs, creation of more efficient batteries, development of new materials, and optimization of chemical reactions. Quantum algorithms can significantly speed up neural network training and big data processing. This opens up new possibilities in artificial intelligence. Additionally, solving optimization problems in logistics, finance, and production can become much more efficient thanks to quantum algorithms. To date, quantum computers with several dozen qubits have been created. In 2023, IBM presented a processor with 433 qubits, and Google achieved quantum supremacy in certain tasks. Of course, many problems and challenges remain. These include scaling the number of qubits, reducing the number of errors, creating practically useful quantum algorithms, and developing quantum software. Experts predict that over the next decade, we'll see quantum computers with thousands of stable qubits, first commercial applications in chemistry and finance, development of quantum internet, and new quantum algorithms. Quantum computers are not just the next step in the evolution of computing technology. They represent a completely new approach to information processing. Although we're still far from creating a universal quantum computer, we're already seeing impressive progress in this field. Perhaps in a few decades, quantum computing will become as commonplace as today's smartphones, and who knows what other amazing discoveries await us on this path.